Hello friends, welcome to FoxuTech. So last couple of videos are the couple of posts on FoxuTech.com. We are seeing mostly about Kubernetes troubleshooting guides along with the GitOps topics. So today we're gonna see about another Kubernetes troubleshooting or the related to Kubernetes. Another topic is it's related to pod again. So we're gonna see important things. Let's jump into that. So as we are all running on the modern world, the Kubernetes world, so we can say, so this world is like we are always create spots. So there could be a different reasons. The reasons can be multiple, right? So we create the pods to any kind of a rolling updates, or there is a scaling the deployments, or there is some news releases coming, or there is some job on the cron jobs we are running. So anything, right? So for all these operations, always there should be a pod to be created, and that will take care of our jobs, right? Anytime you surprised or anytime you thought, so what happens when we are just applying the kubectl, apply the pod name, right? So let's say like this is our manifest for the pod demo. And here what we are doing, we are just creating Nginx. So Nginx pod, and it's exposing a port 80, right? And this is named as a pod.demo. So what happens whenever we are doing this file or when we do kubectl apply? So what happens? So we'll see that here. So when you are giving a kubectl apply, immediately that is received in the control plan or master node, right? So this will be first received from by the API server. API server collect the manifest and it reads that, and the same time what it does, it just store the data on the etcd to make sure our data are maintained on the whatever who are requesting the etcd serves the purpose. Once it's stored, then it's moved to the scheduler queue. So in scheduler queue, what happens? So there's a once it's moved to the scheduler queue, so immediately scheduler, this is nothing but Kubernetes scheduler or kube scheduler, right? So immediately it's again reads that definition or the manifest, whatever it's wrote. So it reads that what it's going to do, or like what is there any resources required, and what is the detail provided on the particular YAMLs. So it's even stores the check the name and port etcd, right? Whatever we are giving on the particular definition, everything it reads on the scheduler, reads by the scheduler. Then what the scheduler does, it identify the proper node to assign this pod. So let's say like you have a 3 node cluster. There's node 1, node 2, and node 3. And as per the round robin algorithm, so our clusters run different, assign the pods based on the round robin. So let's say like if node 1, node 2 already assigned, and now there is a third node should be assigned. Immediately what it does, it's check the node details and compares this resource definition. If it matches, it's assigned to this third node which is available, or again it's validate the details on the remaining node, whichever it suits. The scheduler will be scheduled to the particular nodes, right? So once it's say like I have scheduled it, so immediately the status in the etcd will be changed to scheduled from pending. So you may see there is a pending was assigned first, and then once we given all those details, it's changed to the scheduled, right? So this is not the end again. So this job's just done on the control plan. Plan does that did this work. So next task, it's very important where it's actually work starts, right? So far we just given the definition and stored the etcd. So next important topic, next important guy come to the picture is Cubelet. As we know, it runs on the workers. So what Cubelet does, it's keep ask the control plan, is there any pod for me, right? Just it's a funny, but it's just keep all the status. It's is there any task for us? The particular node, it runs on the each node. So let's say one of the node it's asking, so the scheduler checks there is nothing, so then it's respond to the no. But if there is a yes, so as we are now scheduling the new pod, so obviously the answer will be yes, right? So when it say yes, immediately Cubelet, what it does, it's request for the details. As there is a new pod to be created, could you please give me the data about what I have to do? The manifest definition will be shared from the control plan to Cubelet. So Cubelet, what it does, immediately it reads that and it's assigned all the tasks to the, there is some three CRI, so three interfaces. One is nothing but container runtime interface, container network interface, container storage interface. So this three is a very important thing to schedule the pods. Why? Because container runtime takes care of the running the particular pod like as like a cube Docker, right? So you may run Docker run, right? So as like a Docker run command. So here also the kubelet does the same thing. It's just runs the pod and contain CSI like a storage will be just check is there any mount definition is given. If there is any mount definition, it's take as the mounting point, right? So this is take as run point and this is take as storage point. And then this is a very critical or one of the important layer or the interface is container network interface, right? So what this does, so this is the primary job it does, like it's just check the IP free IP address and it's assign the IP address first. Once the IP address has been set, so then what it does, and also then it's add that particular port to the already existing network. So now the job is done. So once this all three guys are done their work, they update to the kubelet, right? So is it the final state? If you ask me, no, still it's not done. Why? Because so far that updates everything done only on the kubelet or the worker side. Still the control plan thinks this pod is in scheduling stage, right? So and it's wait until kubelet says, hey, this is done and this is the current status of the pod and this is IP address, all the details provided, right? So until then it will be on a scheduled. So let's say like a kubelet reports to the control plan says that, hey, the pod is active or running and this is the IP address. So once it's went to the control plan, so control plan update the status on the etcd again. So in the etcd from the scheduled, right? So we seen it's been scheduled and now it's set to running. So how that look like? So that will be look like this. So this is how it's look like. So control plan, it stores the pod name and what is the status and which node it's running and what is the IP address, right? So this is pretty much done. And when you are just running a simple pad, so then your work is done. So your pod is successfully launched and you will see that status, right? So that is work is done. But when it's coming as a service, so mostly we will run the pod, not only the pod we runs, but there is objects needed. Sometimes we may run the pods with services. So what happens when we are running the pod with services? Now the pod status has been changed to running, but does we can access it? No. Why? Because this is completely it's beyond some services. So if you have a services integrated with the pod or if you are deploying any services immediately, so the pod will have a reference of the particular pod and that will be stored in the YAML file, right? So let's say like you are trying to launch one of the service. So that service YAML looks like this. So what this does, so you can see it here. So there is a two important things in whichever service you are running. One is it is a which is the backend, like which selector I should take care, and what is my target port. So if you are working on the services, this two is a very critical point thing we should always know about it, right? So let's say like this is what we have identified, and let's say this is a pod, right? So service 1 and pod 1 and 2 is part of this service 1. So in that case, what happens? Immediately the pod IP details will be shared from the etcd, and the etcd will create another table, so which is nothing but service table. In the service table, what it stores? It stores what service it is and what is the endpoints. Endpoint is nothing but it's a concentrator of, so your IP address and the port, the target port, right? It's combination of both. It's collect the IP and creates the port. Like this, whatever the number of pod you are creating, everything will be appended as a endpoints here, right? So this is how this table look like, and here the main picture comes. So are we done here? No, not yet. Still the service is not done. Why? Because still further operations are there. So let's say like you are why? Because, so okay, let's come to this back. So before that, let's say like what happens if there is a new pod, no, pod got deployed. Let's say like you have scaled your deployment from 2 to 3. So what happens? Immediately again the kubelet will update the details to the control plan. Say there is a new pod has been added to the service, and if it's a service related, again the service for this service, and that details will be stored again on the etcd with the detailed current status and which node and what is the IP address. So again, with all this detail, again this endpoints will be created. So you can see that like a what is the IP address and target details. You can see this by default if you are running a kubectl get endpoints command in your Kubernetes cluster. You could see two things, or services also you can query. Whenever its services are created, immediately on the backend endpoints are created. You can just run the kubectl get endpoints command. That way you can see the endpoints. All right. So this is for the creation. What if there is one pod got deleted? So the third pod we have deleted, or the we have scaled down, right? So what happens immediately? Again, Cubelet says, hey, there is a pod got removed and this is no more inactive. So again, if there is a part of services, you can see the pod tables are updated. Same time, if it's part of service, even in the service, the endpoints will be removed for the particular pod, right? So this is important. Again, why we are just explaining the endpoints, because endpoint is very critical on the Kubernetes. So it's widely used by the multiple services, not just one or two. So you can see it here, the list we have given, like a service message like Istio or Lingard if you're using. So that I even rates the endpoints, not the services. And you are running the cloud providers, either it can be EKS, AKS, GKE. So if you are putting as a type as a load balancer, again that load balancer reads endpoints, or there is a multiple operators even reads the endpoints. So here the services, it's not actually it's serving the purpose. So we will be seeing in the backend the another slides, but this is just a pretty much information we should now know. So why the Q endpoints again important? What is the major operation it does? So one of the main important details is QProxy, right? So let's say like your pod is created and it's been updated to the services, right? And it's updated as the endpoints. So immediately there is a one of the major guy or the major object which reads the endpoint is QProxy. Immediately what QProxy does when there is a new endpoints are added, thus those details will be stored in the QProxy, and it collects all the data, and it immediately creates the IP table rules in the selected nodes. As we know, the backend of Kubernetes or Docker, it's set out the IP rules has to be created. So that operation will be done by the QProxy in Kubernetes. So for that, it reads the endpoints. If you are serving for the services, then it's create the rules. Okay, this is one guy, like a QProxy is a one guy who utilize as like QProxy. Another important resource we know is Ingress, right? As we are using a service, mostly it's externally exposed using Ingress controllers. So what happens whenever there is a new traffic comes? So as we said, it's mainly this Ingress is reads the endpoints. How it's reads, we'll see that now. So let's say like you are getting some request like abc.com. So that will be again checked by the Ingress services. Hey, there is a request, right? So immediately that will be passed to the pod. And what this pod does, right? It's keep check the tables in the control plan or the etcd table. So one is like a service table and another one is it creates the Ingress names. Mostly the Ingress manifest, what are the detail it contains? It contains mainly which service I should look for, right? So let's see that one example, Ingress here. So this is the Ingress file. So you can see it here. So which service it has to be take a look and what is the endpoints. Okay. So we know that what is the prefix it should use and those details will be stored on the service tables, right? So what Ingress that it just reads this name as a reference, service name as a reference, and it's pull all the data on the endpoints and it stores. Okay, so from these endpoints, it's take as the prefix details and it's upon that directly. So it collects the endpoints and these endpoints, it's reach the endpoints directly without reaching doing anything on the services. It's directly go to the pod and it's pull the data or the traffic and it's out to the users. Okay, so this is how it works overall. So if you are running a services, please be sure like it's actually the service are defined properly with the proper pod details. Why? Because the endpoints are most important and the target port, right? So with that, what is happens again, as we seen, the endpoints are created. Endpoints will be utilized on different places. So this is about this. And what happens? There is a, let's say you are creating another node, like you are scaling up your deployments, right? You have a 2 and now you want to scale to 3. So what happens when you're putting a third node or third pod in your place? So immediately this will be like as we seen initially. So the data will be stored, pushed to the pushed by the Cubelet to the control plan, and that will be updated on the etcd table with the all the details. So and then if it's a part of services, again the service will pull all the pods details and the pod details will be saved as a endpoints, right? So then the Ingress, what it does, as Ingress as a reference like a service name. So the service, sorry for the typo, and this service name will comes and from the service name it retrieves all the endpoints details and it stores to the pod, Ingress pod, and Ingress pod reach to the directly to the destination pods and it's pull the data and it serve the traffic to the users, right? So this is what it's happen across every time. So whenever you are running any pod, so based on the scenarios, its operation differs. If you are just running a standalone pod, so it will be quicker and it doesn't do anything much. Like it's just done by the Cubelet and it's updated to the users. But in case if you're running beyond any kind of a services, then the endpoints are created. The endpoints will be served by the different tools and it's served to the users. So what are the tools it's been utilized? One is QProxy for creating any kind of IP table rules. And second thing is like Ingress. So get the endpoints from the service reference and serve the traffic to the users. That's like same thing. It's applicable on not only Ingress. So service mesh also does the same. It refers from the services and it's pushed to the serve the traffic. And if you are using something on the cloud providers, any cloud provider, let's say Azure Kubernetes, CKS, or Cube, Google Kubernetes Engine. So everything, if you are using a load balancer as a service, so that even refers this particular endpoints in the service table, right? So this is what it happens. So hope this is helpful, guys. So we have even wrote us a blog, this page. I'll be adding in the description. So you can just, if you like to read it, you can read it. Or if you just only like to watch, so hope this video will be so useful for you. So we'll come with next important topics very soon. So it's maybe a continuation of this. So we'll see that. And why we should understand all this. So this is help us to troubleshoot any issues. So let's say like you are running any kind of your ingress is not responding properly and says, so you no need to take a look on the services. Mostly it will be due to the pods. So you can just expose these pods and see what is happening. So if there is any issues, so you can troubleshoot here, and you should know which layer it's happening, right? So if there is a individual pods are responding properly and there is no responses coming to the ingress, so there will be different issues. Either there is no proper updated happened, or there will be a different aspects. So we will be taking look on that with some other in other videos. So we're gonna see that, but this is details for now about pods. But we'll see in the next videos what we can, how we can troubleshoot, or how, what is the other details we should know about pods and other services and ingress everything, right? Thank you guys. Hope this is helpful. So have a great day. Thank you. Bye bye.